at relations and functions. Now, this is something you've definitely done in Algebra 1 before. It shows up in a lot of math classes along the way, so it's really a good thing to try again and again. So the first word we're going to talk about is the word relation. That's a set of ordered pairs. X and Y have a relation. They're working together. When we look at domain, they are the X values. We call them our input. Our Y values are called our output. Now, if you get confused, I'd like to try to remember things a certain way. So X and Y, if you were to put them alphabetically, X comes first. So domain also comes before range in the alphabet. So if you're not sure about that, that's one way it's an easy way to remember. Now we're going to look at function. A function states for every input, there's exactly one output. That's the phrase that math teachers say again and again. And what that really means is a relationship in which the domain X is paired with exactly just one range. Now, the vertical line test is my favorite way to figure out if something's a function. If you draw a vertical line and it only ever hits the graph at one point, then it's a function. So I like to graph them, even if I'm not sure, I just plot the points. So let's look at this first. And if I were to sketch this graph, every time it's only hitting that graph at one time, every time I did those vertical lines. So this one is a function. This one is definitely a function. You look at this option there, second option. If I were to draw a vertical line there, it only hits the graph one time. But over here, it hits it twice, or anywhere else it hits it twice. We only need to have that happen one time to state that it is not a function. Now, when we're talking about domains and range and ordered pairs and different things with relations, we can display these in a series of ways. We can show it as an ordered pair. We can show it as a horizontal table. These are really just things that go together, right? Just displayed a different way. We can also show it as a vertical line, as a vertical table there. A vertical table. We can also plot points. So a couple things here, just as a reminder. This is my y-axis. This is my x-axis. If we're talking about quadrants, this is quadrant 1. This is quadrant 2. Then we go in counterclockwise motion. This is quadrant 3. And this is quadrant 4. Just kind of a good time to talk about that. This point right here in the center, you should remember, is your origin. Now, I can have points kind of anywhere. I can display those domain and range in a different way there. So I can also show them in a coordinate plane. I can also do it by mapping. Mapping is not something you see a lot, but it does come up where it just kind of looks like this. You have two blocks and the arrows are pointing from one domain to a different range or a series of ranges depending on the specific points given. All right, so now we're gonna practice some. So we're gonna state the domain and range, and then we're gonna decide if it's a function, why or why not. Okay, so in my first example, I have ordered pairs. So remember, my domain is all of my X values, and I'm gonna state them in ascending order. So my 6 comes first, then my 7, then 8, and then 10. And that's how I state my domain, and the little brackets that I use. Now, if I'm gonna do my range, I'm looking at 3 and -2 and 4 and -9. So again, I want to state that in ascending order. So -9 comes first, and then -2, and then 3, and then 4. Okay, now we'll do the next one. Talking about domains. Again, this one's a little easier to see visually because it's in a table. So I'm going to list 1. Now, 1 is listed twice here. When I'm listing the domain, I only list each one once. Range, the same thing. I have all my values here. So I have 3, 4, 5, and 7. Okay, now let's decide if it's a function or not. Let's look at the first one. So I have 6, 7, 8, and 10 looking up here. They're only attached to one range. So yes, this is a function. And the reason we're going to say is for every input, there is exactly one output. So that's our reason why that works. Let's look at number 2. Now, the problem we have here is we have 1, right? 1 is attached there to more than one value. So this is going to be a no. This is not a function for the opposite reason. We say that the domain 1 of 1 is paired with 3 and 4. And for it to be a function, it can only be paired with one value, not 2. So that's why that one is not a function. Now, this mapping, I find sometimes this mapping is a little bit overwhelming. So we're just going to kind of take it one thing at a time. So I have my domains. Now, again, they're listed nice and neat. So I have them in order. I have -3, 0, 1, and 5. My range, again, is over here. So my range is -4, -2, 0, and 2. Now, let's do this function right now. Is it a function? So the problem really is this 0. It's fine. Do you see how 2 go to 0 here in my range? That's okay. That's would not impact whether it's a function or not. It's this 0 right now. That 0 goes to -2 and to -2 and to 0. So that makes it not a function, right? It's paired with 2 values. So we're going to say no, that's not a function because 0 is paired with -2 and 0. So that's a no. All right, let's look at our next example. We have, this one's in a graph. So my domain, my x values, I kind of have to read my graph there. So I have -6, and I have 3, and I have +6, right? My x-axis is here. Now when I'm looking at my y values, I am at 2 and 6. So there are 2 values there at 6 for y. Now, is it a function? These 2 values at 6 for y does not matter. Remember, this is an easy one to do my vertical line test. I did my vertical line there. I didn't do that very well. Let's try that again. I do my vertical line there. I'm only going to hit that 1 point. Same thing here. I'm only going to hit at 1 point. Only going to hit at 1 point. So that looks pretty good. So is it a function? Yes. Why is it a function? It passes the vertical line test. So I'm all set. So there's a couple examples for you. You can, take a look as you're completing any assignments or problems that you're doing in class or at home. Okay, the last thing we're going to look at is function form. Now, function form is when equations are represented in function form. So it's really an example. It doesn't really change too much. So here is an example of an equation, right? It has an equal sign. If I want this to go to function form, this is the only thing that changes that y. And I just say a function of x is equal to 2x plus 3. Now, why do I say that? Remember, x is your input, y is your output. So it is a function of x. Whatever going on with x is going to impact what's going on with y. So that's why we write it that way. Now, looking at a couple examples of that right here, they're always going to give you a function. It's going to say find each value. So given the function, now this is how we say it. F of x is equal to 2x squared minus 8. So that's my function. I want to know what f of -5 is. So I'm going to write it like that. Now, everywhere I see an x, I'm going to put a -5. And I see f of -5 is equal to 2 times 25 minus 8. So that gives me 50 minus 8. So my final answer, I'm going to say f of -5 is equal to 42. That's how I write that. Let's look at the next one. This time I have f of 2y. So let's see what happens there. So I have f of 2y is equal to 2 times 2y squared minus 8. So that gives me 2 times 2y squared is 4y squared minus 8. So I'm going to have f of 2y is equal to 8y squared minus 8. Okay, our last problem for today, we have f of x plus 3. So I have substituted that in. So I have 2 times the quantity of x plus 3 squared minus 8. So I'm going to take 2 And then I'm going to have, this is going to be in a bracket. I have x plus 3 times x plus 3, close my bracket, minus 8. So I have 2 times x plus 3 is x squared. X plus 3 times x plus 3, I'm going to use FOIL. So I have x squared plus 3x plus 9 minus 8. So I'm going to combine my like terms. I have x squared plus 6x plus 9 minus 8. Distribute that 2 through. So I have 2x squared plus 12x plus 18 minus 8. So in the end, I'll combine my like terms. F of x plus 3 is equal to 2x squared plus 12x plus 10.